So in section 4.6, we want to talk about the tangent, the cotangent, the secant, and the cosecant graphs. For the tangent function, we have vertical asymptotes corresponding to when the cosine or the denominator of our tangent function is 0. That's going to be at the odd pi over 2's. So minus pi over 2 to plus pi over 2 is going to form my first complete period. So if we look at the graph for the full picture, we start with a vertical asymptote at minus pi over 2. By the time we hit minus pi over 4, we were up to minus 1. When we hit x equals 0, the y value is 0. At x equals pi over 4, we're back to the tangent function giving us 1. And as we head towards pi over 2, we get another vertical asymptote. So again, we have effectively 4 subdivisions or 4 intervals on my full period from minus pi over 2 to pi over 2, which means I want to take my full period of pi units and divide by 4 to get my hash marks. It does repeat periodic with period pi. And so if we look at a specific example, we just have to remember that we want our argument of the tangent function to be between minus pi over 2 and plus pi over 2 to start. So if we start with our argument 3x minus pi over 4 between plus and minus pi over 2, adding pi over 4 to both sides gives me minus pi over 4 on the left, cancels in the middle, and on the right I'll get pi over 2 plus pi over 4 is 3 pi over 4. Dividing everything by 3 gives me my base period should go from minus pi over 12 to 3 pi over 12, which means my period is the difference between these two. And remember, when we do minus and negative, we'll get plus, so 4 pi over 12. And the hash mark should be every quarter of that, which means every pi over 12. So at minus pi over 12, I have a vertical asymptote. I should be at minus 4. Remember, my coefficient is 4, so I had a vertical stretch of 4. This is pretty much always your standard. Whatever that coefficient is where you should put your vertical marks. So I get a minus 4 at 0. At pi over 12, I'm back up to 0. At 2 pi over 12 or pi over 6, I'm up to 4. And at 3 pi over 12 or pi over 4, I get my other vertical asymptote. Okay. So this looks a lot like a cubic function, except obviously cubic functions don't have vertical asymptotes. When we look at the graph of the cotangent function, it's kind of a reflection or mirror image of the tangent function, but we're not actually reflecting across the y-axis. So we're going to get vertical asymptotes at 0 and pi, and it's going to go down with the same pattern that we had before. Same deal, my period is pi, but now it goes from 0 to pi, and I have to remember that for my cotangent. So if I wanted to do an interesting cotangent like 2x plus pi over 4, I do recognize the 4 is going to give me a plus and minus 4 as my vertical markers. And now I want to stick my argument between 0 and pi, which means I'll subtract pi over 4 all the way through and get minus pi over 4 is less than 2x is less than pi minus pi over 4 is again 3 pi over 4, which means dividing everything by 2, x should be between minus pi over 8 and 3 pi over 8. So that's 4 pi over 8 or pi over 2, which means my hash mark should be a quarter of pi over 2 or every pi over 8. So I get minus pi over 8, 0, pi over 8, 2 pi over 8, which we can call pi over 4, and 3 pi over 8. Cotangent starts up at infinity and goes down through our 4 points. So 0, 4, pi over 8, 0, and pi over 4, negative 4 are my markers. Okay, if we're going to draw the secant or cosecant graphs, we're going to basically reflect them off of the sine and cosine graphs. So if I want the cosecant graph, what I usually am going to do is I'll just draw my sine curve first for a full period. And then I'm going to recognize that the zeros of the sine function are going to be zeros in the denominator for the cosecant. So my x-intercepts for the sine function give me vertical asymptotes for the cosecant. And so I'm going to reflect or bounce off of the maximum and minimum values with vertical asymptotes. So it looks like kind of a right side up bowl and an upside down bowl. For the secant, if we're going from 0 to 2 pi, which we usually do, we only get half of the first bowl, we get the upside down bowl, and we get the other half. Recognize because secant is 1 over cosine, we're going to have problems or vertical asymptotes when the cosine is 0, which will be at pi over 2 and 3 pi over 2. So the basic idea if we're sketching a secant or cosecant is we just sketch the sine or cosine graph that goes along with it, and then we flip that over. All right. So if we do a couple of these, let's say we do 3 secant of 4x minus pi plus 2. The plus 2 will be up 2. The 3 is going to correspond to my original amplitude. And I want 4x minus pi to be between 0 and 2 pi. So I add pi all the way through, and I get pi should be less than my 4x, should be less than 3 pi. Divide by 4, and x should be between pi over 4 and 3 pi over 4. So my period is only pi over 2 1/4 of that means my hash mark should be every pi over 8. And so when I draw my cosine, I would actually start my cosine at 3 and go down to 0, but because I'm shifting up 2, I'm going to start at 5, go down to 2, down 3 from there to -1, back up 3 to 0, and up another 3 to get to 5. And then we just flip those. And so the black graph is what the graph of 3 secant 4x minus pi plus 2 is going to look like. Okay, similarly here, if I've got 5 cosecant of 1/2 x minus 3, cosecant is going to be based off of a sine function. So my sine function is going to have an amplitude of 5 shifted down 3. So instead of starting at 0, it'll start at -3, go up 5, back down 5. I do have to be careful. I know my period should be 2 pi over the coefficient. So 2 pi over 1/2 is 4 pi. Or again, you can put 1/2 x between 0 and 2 pi. That means my hash mark should be every pi units because I should take my 4 pi and divide by 4. So again, going back to my graph, I should start at 3 units down, go up the amplitude of 5 to 2 when I hit x equals pi. X equals 2 pi, and back down to what 0 was, so I'm down to -3, down 5 more because of the amplitude to -8 by the time I hit 3 pi, and back up 5 to -3 by the time I hit 4 pi. That would be my one graph of the cosine, or sorry, of the sine. And so we flip that, and the black graph, those two pieces, are going to give me my graph of 5 cosecant of 1/2 x minus 3. All right, so the big thing to remember is going to be the tangent has a period from minus pi over 2 to plus pi over 2. The cotangent has a period from 0 to pi. And if we're going to graph a secant or cosecant, we'll graph the associated sine or cosine first and then quote unquote flip it.